Welcome. So this part, uh, uh, part like of the fundamentals of integrals, and just continue similar like we understand the fundamental of higher order integration and practice do some FE problems. Okay. Uh, so here is so just as you can successively differentiate a function, you can also successively integrate a function. If a function is integrated twice, it's called double integral. So this guy is called like a double integral. This guy is called like a triple integral. Yeah, this is double because integrating it once and then integrating it twice. These are just different notations. So like this is if you read this in a book or a research paper or whatever, something that looks like this is equivalent to this. So here like R2 means that's the double integral of my f of xy. I'm integrating first with respect to dx and then with respect to dy. That is an equivalent notation here. And that is also an equivalent notation to this guy. So like this guy has three equivalent notations. Similarly, dx dy, that is also an equivalent notation to area, because area that's like dx dy that give you an area. Same thing for like a triple integral. So this is an example of a triple integral. This notation is similar to this notation, is similar to this notation. And this notation here is similar to dv. So dv means dx, dy, dz. And we will see a lot of these when we get to differential equation and things like that. But anyway, and the conservation of mass, like sometimes you can use this, sometimes you can use this, yeah. But anyway, just some rules that you can, successive integration do not need to be with respect to same variable. So I don't need to do successive integration with respect to same variable. It's obvious here like dx and then I'm integrating with dy. So I have a function, let's say my function is x squared plus 2y, yeah, dx dy. In my first integration, I will integrate with respect to x, y will be treated as constant. In my second integration, I will integrate with respect to y and x will be treated as constant. So that's basically what the second rule here say variable not included in the integration are treated as constant. Yeah. Start with the inner integral and move outward. So like you start here, for example, with integrating with respect to dx, then integrating with like respect to dy, and then integrating with respect to dz. Like three simple hints that you just need to pay attention when you solve these types of problems. So let's just do a simple example here. Is again, these are easy points in the FE exam. So we have here this double integral with respect to x and with respect to y dy, and let's just do it. So we can start with integrating this, solving the inner integral. So I will start by solving this one here, yeah, and then after this I will solve the outer integral. So the inner integral, that would be dy, yeah, with respect to dx. This will be treated as constant, this will be treated as constant. So that, again, this is why these things are trivial. So that would be y, because that's a constant, so the x here plus x squared and you divide by 2, yeah, x squared you divide by 2 times y, yeah, plus constant. Let's call this constant number 1. Yeah. So now I did solve the first integral. Now I can do the second integral, the outer integral, like this guy. Yeah. So this guy would be what? So this guy would be x plus x square y square over 2y. Yeah. Plus my constant 1. And I'm integrating these guys with respect to what? With respect to dy. Yeah. So now x will be treated as constant. So if I integrated this with respect to dy, so x is a constant, so I get y to the power of 3 divided by 3 plus x squared y to the power of 2 divided by 2. 2 times 2, that's 4 plus c1y plus constant number 2. Yeah. So that is like a very easy problem to solve, and you should that should be easy points both in this exam and homework and FE exam also. Okay, let's look at more like where you have to form the integral yourself. So let's look at this problem where I'm not giving you the integral, but you have to form it yourself based on your understanding of the problem context. So find the volume of a cylinder with radius 3. So like the radius here, this is given is equal to 3, and the height of 5, so z here, that's giving is equal to 5 using double integral of a cylindrical coordinate. So here I have like my dr here. That's the r. It goes from 0 all the way to 3. I have like my d theta here, which goes from 0 to 300, like 60 or 2 pi. Yeah. And I have like this is my radius here, r d theta. So how could the volume, yeah, so the volume like my dv, yeah, the volume would be equal to what? Like my dv here, that would be equal to what? So that would be equal to uh, the r d d theta, yeah, that's like r d theta, uh, well, like time r, yeah, time dr, time delta z, yeah. So that would be r, the r, the r d theta, yeah, time r data dr time dr time d delta z, yeah, so z here, yeah. Okay, so the volume would be equal to the integration, yeah, the triple integration of like of r d theta dr dz, yeah. So can I arrange this and put like some limits here? Yes, I can arrange this and put some limit here. Uh, okay, let's arrange this first and then put some limits here. So uh, I would first say, let's just put these guys here. I will like bring my r here and dr here. So I would first like to integrate with respect to dr, yeah. And then I would like to integrate maybe after this with respect to d theta. You can choose any order you like, and then with respect to dz. Your. Now let's put the limit. So when I integrate with respect to dr, we know that r, this is r, yeah, r goes from what? From 0 to 3. So I will put here 0 to 3. I'm integrating with respect to d theta. D theta goes from what? D theta goes from 0 till like pi, and then till like 2 pi. Yeah. So this goes from 0 till 2 pi. And z goes from what? So z, I know it goes from like, let's assume here, this is like your 0 and this is like your 5. So it goes from like 0 till 5. So because it's here giving me like 5. So 0 to 5. Yeah. So basically, I have my integration set. So which one should we start with? Let's start with this guy. Yeah. Uh, let's start with this guy. So if we started with this guy, I will say like the integration of this guy r that will give me what? That is equal to this r square, yeah, over 2, and then I evaluate this from 0 till 3. That's equal to what? So I evaluate this from 0 to 3. So like remember how to do this without mistake. So to do this without mistake, you put like 3 over minus uh, r 0 square over 0. Yeah, I'm just doing it systematically, but because that could not necessarily be 0, but in that case, yeah, you can just ignore this guy. So that basically will like 3 over 2, that will give you 9 over 2. Yeah, okay. Uh, now I have like my this integral give me like 9 over 2. That's like a constant, so I don't need to keep let me just, so I can just do the second integral. So my second integral, that would be from 0 to 2 pi. And I can include this constant, it doesn't hurt. But, oops, like 9 over 2, yeah, the theta. So that will give me 9 over 2, 0 over pi, the theta. That will give me 9 over 2 theta, and I evaluate it from 2 pi over 0, and that would give me like 9 over 2 pi. Yeah, okay, and that will give me what? So 2 will go with the 2, that will give me 9 pi. Yeah, so now I have my second now, like let's do the last one. So the last one is from 0 to 5 to 2 pi, like this, delta z. And you see here, this guy is a constant, so I can get this. This guy is a constant, yeah. So I can get this guys out. So that would be 2 pi. I get this guy out, and that would be like z evaluated from 0 to 5, and that would be like 5, yeah. So that's 9 pi times 5, and that will give me what? So that will give me 45 pi. Okay, so basically that's the solution. This volume is equal to 45 pi. Yeah, and if we did this like as indefinite integral, guess what we're gonna get? We're gonna get this. Yeah, if we did this as an indefinite integral, because you are getting here r over 2. So like if I solve this as like an indefinite integral, v r d theta dz. If I solve this as an indefinite integral, then what you get, I will, for this guy, I will get r square over 2. Yeah. And for this guy, I will get theta. And for this guy, I will get Z, yeah, and so that will give me like theta for like would be like 2 pi, yeah. So that would be 2r square over 2z, yeah. So this would go away with this guy, and sorry, where 2 and pi. So you get pi r square z. Yeah, that's exactly what you get, like pi r square z. Okay. Okay, so this is just an example here. So the volume, just to give you the equation, pi r square z. Yeah, that's the volume of a cylinder. Yeah. Uh, Here is a practice problem. I will solve it in the tutorial. Like try to solve it in your own and then check the answer here. So if I did this correctly, the final answer should be something like this. And this is a homework problem, yeah. Okay, so that's all for this video, and see you in the next video.